I'm Anil Kumar, sharing with you some questions which will help you review vectors. The question here is, given points P 1, 3, minus 2, Q 2, 1, 1, and R 6, minus 7, 13. Show that P, Q, and R are collinear. Determine the ratio in which Q divided PR. So that is the question for you. You can pause the video and answer the question. So let's first understand it. We need to show that these 3 points are lying on the same line. Collinear means on the same line. So kind of like this. Let me just draw a line here, right? So we exactly don't know where these points are, but the way this question is written, determine the ratio in which Q divides PR. That means let's assume P is here, Q is here, and R is there. Okay. So the ratio will be Q is somewhere in between. This is internal division. Q could be outside also, right? There will be external division of the segment PR. So we'll PR segment. Okay. So that is kind of modified question with our understanding. Now let's see how to solve such a question. Now when we say collinear points, it means what? So they are in the same line, right? So there is a line on which these 3 points can be placed, right? So we say they have the same direction, right? So that could be one thing which will prove that they are collinear. Vectors, they are not fixed in their space, so we can always move them also. But anyway, let us see how to solve this kind of a question. So the points are P, Q, and R. So let us find first the direction of each, right? So we'll do P, Q, and Q, R. Okay. So P, Q is, what is the direction of P, Q? So P, Q segment could be OP. If I am checking with reference to a frame, let's say we have origin O here, in that case this becomes the position vector, right? So PQ will be basically OQ minus OP, right? So that is why we subtract these points. So from origin, coordinates of Q minus coordinates of P. So it's an important concept to understand. We've been doing it for a long time. So anyway, so Q is 2, 1, 1, and we'll take away the P coordinates, which is minus 1, minus 3, and minus or minus 2 is plus 2, right? So that becomes PQ, and this is 2 minus 1 is 1, 1 minus 3 is minus 2, 1 plus 2 is 3. Correct. Similarly, let's find what is QR, right? So QR will be equal to, so Q to R. So Q to R, we want this much, right? So QR will be OR minus OQ. So it is OR minus OQ. Perfect. Which similarly I should do, R coordinates are 6 minus 7, let me write them, 13. Take away Q coordinates, which are 2. This is a very convenient way of doing it, very effective, right, and fast. 6 minus 2 is 4 minus 8, and this is 12. Do you see that? So we get these numbers. Now, are they related? What you notice here is you can write QR as equal to, so this is 4 minus 8, 12. This is 1 minus 2, 3. So what I can do is I can factor out 4, right? So I could write this as 4 times 1 minus 2 and 3. Do you see that part? So 4 times this. And what is 1 minus 2, 3? 1 minus 2, 3 is PQ. Wow. So we get 4 times PQ, right? So what we see here is that QR is scalar multiple, right? So it is scalar multiple. So scalar multiple means they are collinear. Is that okay? So that's a neat way of proving the same thing. And we actually get the answer for the second question also, which says Determine the ratio in which Q divides PR. So we know that PQ and QR is 4 times PQ, right? So if it is 1, this is 4. Do you see that? So the ratio is 1:4. Do you see that? So we can now answer the second part of this question. So A is proved, right? This is A. Since scalar multiples means they are collinear, and part B is that PQ is to QR equals to 1:4, right? Because QR is 4 times PQ. Do you understand? So that is the ratio in which Q divides PR, and that is how we can solve this. I hope that is absolutely clear. Thank you, and all the best.